Good morning, good afternoon, good evening, wherever you are. I am Nick Chase from Mirantis, and we are here for today's webinar, the ONAP Overview, Navigating Its Many Projects. Thank you so much for joining us today. We know how busy you are. Let me introduce you to today's panelists. We have Amr Kapadia, who is an NFV strategy orchestrator at ARNA Networks. We used to have him here, but now he is off being the what are you doing now? Training and deployment services at ARNA.
Exactly. ONAP and OPNFV. Yes.
All right. Cool. Yeah, he is also, by the way, the author, the primary author of a book on OPNFV. We also have Madhu Nuna. He is our senior product manager in relation to SDN and NFV solutions here at Mirantis. So he is going to be also talking to us about some of the real world applications of ONAP. Let's talk a little bit about housekeeping before we get into the agenda and the actual content. As you will see, whether or not you have attended any of these before, there is a little question pane, usually on the right-hand side of your screen, where you can go ahead and submit questions for us. We will be collecting these questions and answering them at the end. Also, we will be recording this webinar, and you will have access to the recording and the slides. So you don't have to ask that because we have just answered it now, although probably somebody will ask it anyway, and that's okay. So moving on to the agenda, we are talking about the ONAP project today. So we will be giving an overview of it, along with sort of the philosophy and what it's for, and what's the thinking behind it, because ONAP is not your typical open source project. It's really made up of a lot of different projects. So we're going to go ahead and talk about those projects, give you an idea of what's involved, and then you're going to see how it can improve your network automation life. And finally, we're going to get sort of a real world view of how it can be applied in practice. So let's go ahead. Before we get started, we just want to kind of get a feel for where you are coming from. So I'm just going to launch this poll here, which is basically if you are, we would like to know sort of, is your organization seriously considering ONAP? Are you in the initial throes of it? Are you just kind of thinking about it? Are you just about to implement it? Looking at the results as they're coming in, we're sort of almost evenly split between we're about to do this tomorrow and no, we're not really seriously considering it at all. There's very little middle ground here, which is kind of interesting. There's a few people in the middle ground, but most people are sort of at the far end of the spectrum, where we're kind of they're thinking about it, but they're not really kind of in the throes of it yet. So if that's not you, jump into this poll, because we want to make sure that we are sort of gearing this towards the appropriate level for you. So we'll give it another minute as we have responses still coming in. Not even a minute. We'll give it another 30 seconds. So yeah, it's becoming a bit more evenly distributed, although we do still have people, probably the majority. So we've got 48% is still in 12 months or more, or not considering in the next 12 months. So there we go. And then we've got, well, And then we've got 2546, but the majority are in 12 months or less. So there you go. That's what happens when you try and do the math in your head. So, all right. So the majority are 12 months or less, but it's fairly evenly split. So I'm going to go ahead and close this out now. And let us move on. So Amr, you're going to give us an overview of ONAP. So tell us, sort of, kind of get us settled where we kind of start out here.
Yeah, so let me start at the ETSI NFV Architecture. And for purposes of this presentation, I'm going to assume that the audience is familiar with NFV and the concept of network functions virtualization. So if we look at the ETSI architecture, which has been really pivotal in sort of defining how people think about NFV, there's really, in my mind, 3 layers. The first is NFV infrastructure. That's the infrastructure that your VNFs run on. So it includes the hardware, it includes the virtualization layer, which is compute, storage, and network. So you have virtualization technologies for all 3. And you have a variety of data plane acceleration technologies, excuse me, to make sure that you get decent packet processing performance using industry standard x86 or ARM servers. On top of that, you have VNFs running. These are what people really care about. These are the network functions that so far used to be physical appliances and physical network functions, and they have been virtualized. And these are what actually provide the network service functionality that the operators care about. And then on the right, you have this interesting beast called MANO, management and orchestration. And it has multiple components. The first component is an orchestrator. So the orchestrator, think of a conductor at an orchestra. The orchestrator makes sure that everyone is sort of doing their job properly. So the orchestrator brings up network services, manages their life cycle, manages the virtual network functions or VNFs underneath. Then you have the VNF manager functionality, which manages a specific VNF. And underneath that, you have the VIM, Virtualized Infrastructure Manager, and SDN controller. For purposes of this discussion, we are going to redefine MANO as only the first 2 boxes I mentioned. So NFV orchestration or NFVO, and VNF manager, which is VNFM. So with that, we can go to the next slide.
Tell us, so how does ONAP fit into all this?
Yeah, so ONAP is a MANO solution. And I'm calling it MANO++ because it actually is a superset. And we'll, just in the next slide, we'll look at how it's a superset. But for purposes of this slide, let's say it's a MANO. And it came into being through 2 separate efforts merging. AT&T has had a project called ECOM, and they open sourced it. Simultaneously, there was a Linux Foundation project called OpenO, a MANO project that had been started by China Mobile, Huawei, and many others. And these 2 projects merged. And the merged project is called Open Network Automation Platform, or ONAP. And you can see how ONAP's website defines themselves. And it's actually a really vibrant project, even though it's we are prior to its first release. The first release is anticipated, this month. So the first release hasn't happened yet, and there's so much interest. There's 18 platinum members currently, and 32 plus silver and associate members. And many of these platinum members, as you can see, are telecom operators. So it's a very large percentage of members are actually users.
And what's really interesting here to me is a lot of these companies are typically actually pretty closed source organizations. Telcos aren't usually very open source organizations to start with, sort of historically anyway.
That's actually a really good observation. I think with 5G, NFV, SDN, and edge computing, you are going to see a complete transformation of how telecom operators consume technology. I think they'll embrace open source and a lot of these new methodologies like cloud native and DevOps. So it's going to be a different world in just, I would say, in 3 years.
Yeah, I think they've realized that as one of our engineers put it, no single company could ever keep up with all of the innovation that's required. So they have to team up.
Exactly.
So now what is the scope of ONAP itself?
Yeah, so next slide. So this covers the scope. So ONAP has 3 components. The first component is what is required by the ETSI architecture, the ETSI MANO specification, and that's the NFV orchestration functionality and VNF manager. So that's, of course, part of ONAP. That's the primary function. But it has 2 additional pieces. First is the design framework. It's a unified design framework to design network services, onboard VNFs, and actually design a lot of what they call recipes or management steps. So you can literally construct network services and a lot of things surrounding the network services all in one place. And then there's a big chunk of functionality that has to do with FCAPS, which stands for fault configuration, accounting, performance, and security, which is a mouthful. And I like to think of it as service assurance. So you have the service orchestration piece, and then you have the service assurance piece. And if you ask me, what is the genius of ONAP, right? Why is ONAP so special?
Why is ONAP so special, Amar?
Yes, thank you, Nick. I was hoping you would ask that. So it's so special because it not only has service orchestration, but it also has service assurance, and these 2 are tightly coupled. So there's feedback going on, which ONAP calls closed loop automation. So if the service assurance component detects an anomaly, instead of now opening a ticket and letting a human being deal with it, hours or weeks later, it immediately, through policies, informs the service orchestration piece, which takes action, and now you have real-time closed loop automation going on. And that I believe is unique in ONAP, and that is also the genius of ONAP.
Excellent. So how do we go ahead and integrate all this into the typical telco or CSV environment?
Exactly. That's a great question. So ONAP is not going to be the only piece of software, right? By no stretch of imagination in a CSP environment. So this picture shows what else it integrates with. So below ONAP, you have the NFV infrastructure, the Vim, which is OpenStack in this case for now. Kubernetes may be supported in the future, but for now it's OpenStack. And SDN controllers. So that's what's sort of below ONAP. What's above ONAP are OSS, BSS systems. Then you have big data applications. These are analytics applications, machine learning possibly. And then you have e-services. For example, someone wants to order a movie, right? So then the user is literally clicking on a portal and ordering the service without going through human beings. And then on the left, it shows models. So models are very critical to the operation of ONAP, and we'll look more at models, but these include models for VNF, so VNF packages, VNF descriptors, etc. And then ONAP literally has a model for everything you can imagine. There's models for network services. There's models for closed loop automation. There's models for workflows, etc.
Okay, great. So, all right. So now let's talk about what is sort of the philosophy behind ONAP. This is more of a way of doing things than an actual product, I guess.
Yes, and I think it's very important for webinar viewers to understand what is the philosophy, because it's actually a paradigm shift. ONAP does things differently than what people are used to. So unless you understand the architectural philosophy, it'll all sound pretty confusing. So this shows the primary architecture principles on the left and the secondary ones on the right. And I'll just throw a caveat. These are my opinions. If you were to ask someone else, they might give you, they might move things around on this list. They might move some things from the right to the left and vice versa. But anyway, my list is model-driven. So this is really important in ONAP. It provides automation. So without models, and I think, Nick, you have had some webinars before on sort of infrastructure as code, right? So
yes.
And it's the same idea. So you are codifying your infrastructure in models. And not just infrastructure, services, network services as well. So everything gets codified in models, which means you get the same result each time. It's modular. You can sort of plug different things together using models. And it cuts down on manual effort and the time it takes to, say, design a network service. And most importantly, you get this without coding. So there's no hard coding. You can always write scripts, right? If you want to automate something, you can hire a bunch of software engineers and write, shell scripts, Python scripts, whatever. But that's expensive. So this is a very important principle. And ONAP has models for network services, VNFs, analytics, closed loop automation, workflows, etc. And they also have the design tool that we talked about to onboard these models and to stitch them together to create higher level artifacts such as network services. So that's one, I think, is a very important principle. The next is cloud native. ONAP is a cloud native application, and ONAP encourages cloud native VNFs. So cloud native, I'm not going to go through the definition of cloud native, but I think most people will have some familiarity. It's breaking down a monolithic application into microservices, separating state less versus stateful. So separating state and isolating it, doing your design that is scale out as opposed to scale up, putting the burden of reliability on the application as opposed to the infrastructure. So these, in my mind, are sort of the main cloud native principles. And then it also bakes in a philosophy of CI/CD. And this is also at 2 layers. ONAP itself, if you look at the open source project and how it's created, uses a CI/CD pipeline. And then ONAP uses CI/CD to manage VNFs and network services. So this is quite important because in this new world, it's when you're getting you're getting 5 open source components. They are at different velocities. They show up on different dates. VNFs are showing up on different dates. It's no longer possible to say that, once a year on December 15th, I'm going to upgrade my network service. That's no longer possible. You sort of have to continuously integrate these components as they come in.
And that's probably not a bad thing, because that once a year upgrade was always a nightmare for everybody.
Yes, a very high risk.
So much better to do it incrementally as the year goes on.
Yeah. So in addition to these secondary ones, I'll just hit on some high points real quick. So pluggable, you can plug in. You don't have to use all projects of ONAP. You can use a subset. You can plug in your components. It's policy driven. So the concept of closed loop automation we talked about depends on policies. So you have to set up policies to declare events that then trigger actions. It's real time. So we are talking about the system correcting to events or scaling out or self-healing or whatever other actions may be required in milliseconds and seconds and not hours and weeks. Self-service, so it's at two levels. First, we want self-service at an end user level. So a virtual CPE user, for example, can request services, or the example I gave of a person ordering a video. But we also want self-service within the CSP environment where designers are able to design network services independent of operators. They don't have to, talk to operators for every little thing they're doing. So it's a self-service environment, multi-tenant. Of course, you're going to put multiple services on using one ONAP instance. It's secure. We talked about closed loop automation, and obviously open loop automation is supported as well. Open loop just means that it opens a ticket which a human being then responds to.
Awesome. Okay. So let's go into a little bit more detail as we kind of dive a little deeper.
Yes. So I wanted to give people a flavor of sort of a day in the life of ONAP before we dive into the block diagram. It's in 3 steps. So the first step is actually the burden is on the VNF vendor. So the VNF vendor has to provide a VNF, ideally cloud native, but you could also do package VNFs as cloud hosted or cloud optimized. And these definitions were given by Jonathan Bryce from OpenStack Foundation. Again, I'm not going to go through those 3 definitions, but you have to provide a VNF, and then it has to be packaged as per ONAP requirements. And ONAP does provide some tooling to make this easier. Once that VNF is available, then you move to the operator. So from the VNF vendor, now you're in the operator's world, where the first step is design. All these VNFs are onboarded. There are other artifacts that can be onboarded as well, like analytic applications, etc. And then network services are constructed. These also have to be tested. And once all of this is created, tested, stored in catalogs, it moves to runtime. Runtime, everything is just sitting there until a BSS system triggers a service deployment. It can also be done manually through a GUI, but typically it'll be the BSS system. And once the BSS system triggers it along with providing runtime configuration, then service lifecycle begins. So now the service is deployed, its lifecycle is managed in terms of, post-deployment configuration changes, updates, upgrades, etc. And that occurs hand in hand with constant monitoring, continuous monitoring, and FCAPs. And that's where you get the closed loop between 6 and 7, where you get some monitoring event that triggers a policy that then triggers an action which requires the service orchestrator to do something. And now again, you go back to monitoring. So it sort of goes around as a closed loop. All right, we can go to the next.
Oh, there we go. I'm sorry. That helps if I unmute myself. All right, so that's in general how it works. Now, am I correct in understanding that ONAP isn't exactly you don't download ONAP, so to speak, correct?
Well, you do download ONAP, but it's not one monolithic project. It actually consists of 29 projects for this release. And the number obviously changes. So we are sort of dropping down from a 50,000 foot level to like a 2,000 foot level. So I'm not going to go through all of these projects. We simply don't have the time. But this slide shows you the 29 projects that are approved. And I would like to sort of pop up a level and talk about maybe 4 main categories of projects. So the first major category is design time. So we looked at the design time. Design time is a unified GUI through which You can design network services, onboard artifacts, create management steps, aka recipes. So all of that occurs in design time. There's also a catalog, so it promotes reuse. So once you onboard a VNF, you don't have to do it again for another network service. It's sitting there in the catalog. CLAMP is for closed loop automation. VNF SDK is for vendors to package their VNFs, and SDC is the main service design component. So that's the design time, and we'll look at it a little bit more. Then you have the runtime, and again, I'll wait for a subsequent slide to explain the runtime. On top of that, you have the portal/API. You can either go through a portal or API, and there's also a CLI. And then the last point I want to highlight is the bottom left, which is ONAP Operations Manager. So ONAP itself is a cloud-native application. ONAP needs to be deployed, and the lifecycle of ONAP needs to be managed in terms of updates, upgrades, self-healing, scale-out, etc. So that is done by the ONAP Operation Manager. So it's sort of interesting. There's two levels of activities going on. ONAP Operations Manager manages the lifecycle of ONAP, and then ONAP manages the lifecycle of network services.
Excellent. Okay, so let's talk more about lifecycle then.
Yeah, so let's first look at how the lifecycle of ONAP itself is managed. So being a cloud native software, there's initial deployment, configuration, post-deployment configuration changes, scale out, self-healing, updates, upgrades. In the Amsterdam release, there will be many options. You can use a heap template. And then there are other alternatives in terms of using Kubernetes and containerized ONAP. So many options, but just keep in mind that this is understood to be a critical piece and there's a lot of activity. All right.
Okay. So then how do we, so let's talk about then about the design environment.
Yeah, design environment, I think we've already covered to some degree, but the main two tools are Service Design SDC and CLAMP, closed loop automation. And these two, between these two, you can do all the items we have listed on the left. So, and since we've talked through, I'll go quick. Onboard VNFs, create services, create policies, which are very important for closed loop automation, create workflows. So you might have a workflow to upgrade a network service or back up a network service. Data collectors, which are critical for monitoring, analytics applications, also for monitoring. Then you distribute all these artifacts. It is catalog driven, so once you create an artifact, onboard it, you don't have to recreate it again. Somebody else can reuse it. And CLAMP is for creating closed loop automation. It is role-based, so depending on if you're a designer, a tester, an administrator, or a governance individual, you will see different views of the UI, and you'll have different privileges.
Gotcha. So now let's talk about the runtime environment. So how does this actually work then?
Yeah, so once the design activity is complete, now we move to runtime. So like I said, a BSS system typically will trigger a service creation, and that triggers the entire runtime lifecycle. So there are two boxes here, service orchestration / lifecycle management on the left, and on the right you have monitoring and FCAPS or service assurance, and those two work hand in hand, creating the closed loop. So on service lifecycle management, you can trigger it using an API through BSS or GUI if you manually want to do it. And the main component here is called the service orchestrator, or SO. The description of the network service is in two modeling languages, Tosca or Heat. And the service orchestrator is also provided with configuration parameters. So it has network services, and then there's a concept of workflows. So there are some workflows that are predefined, like service creation or service termination. These are predefined workflows But there can also be custom workflows, like we discussed, where you might say, I want to define a workflow to upgrade my service, for example. So all of this is managed by the SO or the service orchestrator. The service orchestrator then relies on what's called controllers to do lower, quote unquote, lower level functions. I mean, they're not really lower, but for purposes of this discussion. And ONAP has three categories of controllers. SDN controller, or SDNC, is for layer 2 and layer 3 configuration and lifecycle management. AppC or VFC, there are two options actually. They're VNF managers, and they are really for layer 4 through 7 configuration and lifecycle management. And then you have something called multi-VIM, which manages OpenStack today. So, and the name is multi-VIM, which sort of tells you that the goal is to support more than just OpenStack, but right now it's OpenStack. And on the right, you have monitoring and FCAPs. The main monitoring engine is called DCAE, Data Collection, Analytics, and Events. The way it works is you have a bunch of collectors that can be collecting data from anywhere. It can be from VNFs, it can be from OpenStack, it can be from the SDN controller, whatever. And those collectors send data, batch or streaming, to DCAE. DCAE moves data around using an internal bus, stores it as needed. It has a bunch of microservices for pattern matching, for data enrichment, etc., that then goes to analytics applications as required. And through this, you can now say, for example, you can say, if my memory utilization drops, or not drops, but goes over 80%, then I'm going to set a policy to do XYZ, like scale out. And so that will all be done by DCAE, and then it'll hand off the actual scale out action to the left-hand side, which will go to either the service orchestrator or to one of the controllers. And then a very important piece on the right is called ANAI, Active and Available Inventory. So that has complete real-time information of what resources are available and what resources are being used. Furthermore, there's a graph. So there's a graph all the way from the subscriber. What network services are they using? What VNFs are those network services using? What VMs or virtual infrastructure is being used by those VNFs, and how it maps to physical infrastructure. This is vital for root cause analysis. So let's say you have a problem with a network interface card. Then using ANAI, you will be able to map it all the way to what VNFs, what network services, and what subscribers are impacted, and that'll help you take appropriate actions. So ANAI is sort of a critical piece without which, and everybody talks to ANAI, and the whole thing sort of falls apart without that.
Okay. All right. So all of this is great. Now, big question, of course, well, what do we actually do with it? Let's talk about use cases.
Yeah, so this is all sort of abstract unless we can show that it's providing real user value, right? Real benefits. And that's through use cases. Of course, ONAP is a general purpose technology. It can support hundreds and thousands of use cases. But for this release, the community has picked two to sort of flush out the system. There's a virtual firewall use case, which is more of a test and demo. And then there are two that are really meant to check out all the components of ONAP, virtual CPE and VOLTE. So the next two slides, we can look at those.
All right, so let's look at virtual CPE.
Yeah, so this I think is very interesting. It's a residential use case. So to date, a lot of internet connectivity is provided by residential gateways. So these used to be, way back, they used to be modems, and they became cable modems or DSL modems, and they've evolved to residential gateways today. The problem with residential gateways is if you want to add new services, like let's say, edge computing shows up and you want to add AR, VR, or you want to add image recognition, machine learning type for video surveillance, or you want to have some smart home or IoT services, it's simply not possible. This is a rigid fixed function box, and good luck trying to add functionality to it. So there's a new spec called NERG, which splits the residential gateway to just a bridge at the residence. So it's just a bridge, and then all of the rich functionality, network functions, move to the edge or the cloud. So it splits the residential gateway. And what this use case does, it actually shows, orchestrates the entire service. It actually uses BRG, Bridge Residential Gateway emulators. So bridge residential gateways are sort of emulated. They're connected to virtual gateways, which is the other side of the pair, and all associated VNFs that are required to make this work, and with a full demo. So this is something that's available. It's 100% open source, and it really showcases what value ONAP brings. And it's the whole point is operators can increase their revenue through new services and simplify deployment and management.
Amar, I hope I'm not going to kind of throw you off here for a minute, but I would like to just kind of address here the difference between this kind of situation and, say, having a cable modem or such. Like we're presenting this webinar right now through, I assume, a cable modem from my residential internet. What is the difference between this and, say, just connecting, say, all of my IoT things to my cable modem and going to the internet through that?
It's no different. So cable modem can be split up to a cloud cable modem with just a bridge at the residence in the same way. And in fact, Cable Labs is part of the organization that has published the NERG architecture.
I see. Okay, so this is sort of preparation for virtualizing all of this.
Yes, yes.
Gotcha. Okay. So let's talk about VOLTE. So what is this now? Is this sort of the mobile version of VoIP?
That's exactly right. As operators move to a data-only network with 4G LTE and definitely with 5G, it's really inefficient to have a voice service that's standalone, sort of working on the side. It's very expensive. So the point of VoLTE is to basically give you voice over IP end-to-end over the data network over IP. So that sounds easy, but it's actually quite complicated. You need a full virtual EPC service, which is a mobile core network virtualized. On top of that, you need VA virtual IMS, IP multimedia, which you can really think of as a voice over IP telephony service. So you need those two services, and they need to straddle edge and core, right? Because you have the radio and the access side on the edge, and then you have the core where all these voice calls are going through. So this use case shows how you can build a VoLTE service and orchestrate it using ONAP. It is actually quite interestingly, it's different than VCPE in that it uses commercial VNFs and commercial VNF managers, commercial element management systems, and SDN controls. So it's a sort of counterpoint. While VCPE is 100% open source, this one is sort of all commercial. And I think it's very important that both types of use cases are tried out, because that completely exercises ONAP and shows you that you have multiple options and all sort of components are tested out. So with VoLTE, the idea is increase agility, reduce the CapEx, reduce OpEx, and increase the utilization of your network.
Excellent. Okay, so there's a lot to unpack here. So let's talk about, tell us how we can learn more about this.
So a little bit of sort of shameless advertisement.
This is the shameless plug slide. That's okay. You don't have to be ashamed, Amar, because there's a lot of information here. So tell us about these classes.
So this same information that we went through in literally 35 minutes, if we have a training class where we go through it over half a day, and that's the ONAP 100 class. And once the Amsterdam release is out, we will also have a full day version with labs. That'll be a full day. And these are public or private or on-site, on-demand classes.
Excellent. And is there a link for these classes that we can provide, or should people look out for an email? Or
yeah, we can provide it later. It's basically through the ARNA Network's website.
Okay, excellent. So we'll go ahead and add that into the slides and the PDF when we make that up. All right. So Amar, thank you so much for that description to kind of get our context set. Now we're going to move on to Madhu, who is going to show us sort of a practical application of all of this. Let's put this into something kind of concrete. So Madhu, thank you so much for joining us here. Can you tell us a little bit about what you're going to talk about?
Yeah, absolutely. Amar has spent time in going through the ONAP details, where it helps, and all the constituent components and things like that, and some of the use cases. What I'm going to talk about is take a step back, look at it from an operator perspective, from their network reference architecture, as well as operations, and show where ONAP really helps operators, and also take a quick peek at what Mirantis is doing to help from ONAP perspective, as well as from operations automation perspective. So that's what I'm going to talk about. This first slide, what you're looking here, shows the telco network reference architecture, a representative view of the reference architecture. Shown at the bottom of the slide are the physical and virtual networks. Going from left to right, you'll see customer or edge networks, and then you go through the access and aggregation networks. And then all the way to the right, we are showing a virtual network, a NFVI/Vim layer, hosting VNFs, whether they are VM-based or container-based, and that also includes some SDN components for providing virtual networking, etc. And it also includes capabilities for monitoring the virtual network functions, etc., like fault monitoring, alarms, and events, etc. And then sitting on top of that physical layer is the control plane for all of those, both physical and virtual components, whether it's SD-WAN or SDN or even the legacy NMS, EMS components. And sitting on top of that, bringing them all together, allowing an operator to essentially manage end-to-end service orchestration, end-to-end service monitoring, etc., is this end-to-end service management layer that is typically provided by OSS, BSS in the past, and that's where ONAP would fit in the new architecture, new network reference architecture for telcos. And sitting on top of that orchestration or management plane is the portals through which different user communities, whether it's end users or network operations or legacy OSS or other organizations within an operator or in their partner or customer community, can essentially look into the network and perform the operations or activities or create services that are relevant for them, all through the same end-to-end service and orchestration layer, but obviously having customized views and performing customized operations that are relevant for them, for themselves, basically. So this is what ONAP allows you to do, and there is a purpose of that end-to-end service orchestration layer here. So that's taking a look at the telco network reference architecture. Let's go to the next slide and look at the telco operations that are going behind the scenes. This is a very simplified view of telco operations. let's start from the top and then go in a clockwise direction. Service design, this is where an operator comes up with a business case for a particular service. Voice over LTE could be that service, or a virtual CPE based enterprise services could be another service that Amar talked about earlier. And that service definition would lead to the type of network functions that you need to actually be able to provide that service to your customers. And that leads to the next step where you are actually managing supply chain management, the procurement, engineering design of those network functions, where they need to be located in a carrier network, etc. And once those things are done and you have actually validated those network functions and they have placed in the right location, either virtual or physical, then you go into the fulfillment or fulfillment phase, where that service design essentially gets realized in the actual network, thereby providing service to your end customers as satisfying the SLAs or other service level agreements that that operator might have with their customers. And while this sets up the service, throughout the life cycle of that service existence, operator has to worry about operations and maintenance of not only that service, but also the network infrastructure underneath it. And potentially the operator might be making some service changes, and now you go back to the service design phase. This is a cycle that an operator keeps going through. How does ONAP help? If you go to the next slide, since the network service definition itself can be captured in a software-based workflow definition, and unlike in the legacy network, even the network functions are also completely in software. The network function itself is in software, their configuration in software. As a result, you could potentially automate the whole cycle that is shown here on the left-hand side. Unlike in the legacy network management, where each of these boxes that we are showing here would be managed by separate departments, separate organizations, as separate operational silos, in a virtual world, they all can be automated, and ONAP essentially helps in automating each and every one of these components, thereby creating much more efficient telco operations. And that's how an operator can realize the goals that resulted in the creation of the concepts of NFV and SDN, which is bring that agility and reduced time to market for new services, and the ability to fail fast in case of new services, and the cost of failure is extremely minimized. So telcos can compete with some of those digital age companies like Google's and Twitter's and etc. Let's take a look at what Mirantis is working on and how Mirantis is helping operators. Before I talk about Mirantis itself, what I'm showing on the left-hand side is a hypothetical centralized management plane. So you could have a single cloud in a carrier network, which is acting as a centralized management plane, managing all the other clouds, physical or virtual clouds, and those are shown on the right-hand side. So if you dig deeper into what I'm showing inside those clouds here on the left-hand side, MCP or Mirantis Cloud Platform is capable of hosting any application or any virtual network function. In the case of centralized cloud, it could host ONAP as an application on top of MCP and could help in managing the full life cycle of ONAP through MCP components. And then it could manage VNFs that are running on Mirantis Cloud Platform in the distributed NFV clouds shown on the right-hand side. Again, those VNFs also could be, their lifecycle could be managed by MCP, but more importantly, all of these things are fully automated with ONAP and MCP integrated together. So that's the solution that Mirantis is trying to bring to the operator community, and we plan to do more in terms of if and when container-based cloud-native VNFs come into picture. Mirantis Cloud Platform is already well positioned position to support those. And as Amar mentioned, ONAP also encourages vendors to create and define this cloud-native VNFs, and operators would have an easy path forward with a combination of ONAP and MCP going forward. So I think that's all I have today. Yeah, Nick, please take over.
Yes, excellent. Well, thank you so much, Madhu. So that brings us kind of to the end of the content itself. What I'd like to do is I'm going to go ahead and I'm going to launch another poll here. We'd like to know what you all find the biggest barrier to adopting NFV and NFV technologies. And while that poll is up, we would also like for you to go ahead and enter any questions that you might have into the question pane, so that we can go ahead and start to get them answered. While the poll is going, let me go ahead and ask a couple of questions to start with. Amar, we have one person who is asking whether how ONAP is related to OSM.
Yeah, that's actually a good question. So these are two separate projects. OSM, or open source MANO, is under ETSI, and it has some similar elements to ONAP in terms of service orchestration, VNF manager. I believe it even has a GUI to do the design, but it's missing the FCAPS piece, because that's really not required as per the ETSI NFV architecture. So yeah, I think it'll be interesting to see. I'm sure, it's not going to be just one solution for everyone. So I'm sure both will serve specific needs.
Okay. And Madhu, can MCP be federated? The way it's phrased here is can be MCP federated into clusters. So I'm not quite sure how to parse that sentence.
I'm assuming what is being asked is if MCP can manage a cloud cluster, distributed clouds from a centralized location. If that is the question here, the answer is absolutely right. Absolutely yes, basically. So MCP can manage a distributed cluster of clouds, and this is something that we are actually doing at some of our operator customer sites, basically. And if you look at 5G, this becomes even a much bigger requirement, where you could potentially have hundreds or thousands of edge clouds all being managed from a centralized location. And that is also another area that we are actively working on right now, and that is probably one of the critical components of our roadmap going into next year.
Okay. Amar, any plans to have netconf/Yang modeling?
Since we were short on time, I didn't mention all the modeling components of ONAP, but this is already part of ONAP. So for network service design, the languages used are Heat and Tosca, but for VNF configuration, Yang models are used. And then Yang models are consumed by SDN controller, and SDN controller uses netconf or RESTconf. And this could be through SDN controller or APSI or VFC, and they use netconf, RESTconf to talk to VNFs.
Okay, excellent. Which open source project is the SO based on?
So the SO actually is a mix of several open source projects. For the parsing the models, Tosca models, it uses two open source projects. One is called ARIA. ARIA is an open source Tosca parser by Cloudify, and it uses another one that comes from OpenO. So one is imperative, one is declarative toss-up. It also and that's for parsing these models. For the workflow side of things, it uses something called Camunda. Camunda is a BPMN. BPMN is yet another modeling language that we didn't get time to touch on, but it uses that. And then there's databases. I believe it's MariaDB, but I'm not 100% sure.
Okay. Let's see. We still have another couple minutes, so if you want to get your questions in, now is the time. Why do I hear about both Kubernetes and OpenStack in the ONAP context?
Yeah, I can take that. That's a good question. So ONAP is a cloud native application which can run on OpenStack or Kubernetes. So that's one piece of the puzzle. And then the second piece of the puzzle is, where do you orchestrate these VNFs, which currently is OpenStack, and presumably at some point in the future, it might be Kubernetes. So again, to sort of re-summarize, ONAP runs on OpenStack, but very shortly it'll run on Kubernetes. ONAP will orchestrate VNFs on OpenStack, and at some point, maybe Kubernetes.
Okay. All right. Are OVS tapping or port mirroring options available? Do we need to look that one up and get back to everyone?
I don't know that offhand. Madhu, do you know? Otherwise, we'll have to look it up.
Yeah, we had to look it up. Now we are going into the actual Vim itself and talking about what kind of tapping options are available for monitoring, whether it's virtual taps or physical taps. So it depends on the specific VNF, and sometimes some of the SDN solutions also provide some of those things. We can look into those things from ONAP context and provide the answer later on.
Okay. All right. Well, I think that sounds reasonable. All right. So that brings us to the end of our time. I want to thank our two presenters here, Madhu Nuna and Amar Kapadia. And as always, I want to thank our back-end support, Michelle Yakura. And I want to thank all of you for joining us here today. Everybody's always busy, so we really appreciate you taking the time to join us. We will be grabbing the extra questions and throwing everything into a blog post. So don't worry, you won't miss anything. Thank you all for joining us, and we'll see you next time.